started the recording now, which is a-okay. But even though it has elephant toothpaste in the title, you want to make sure that it's not getting, the experiment itself is not getting anywhere near your eyes or near your mouth or even in your nose, which would be kind of silly. But the things we're using today, although not super harmful, are still not things that we should eat or have put in our eyes. And it is just a good thing to do when you're doing science experiments to make sure, like true scientists do, that you maybe have some glasses of some sort on if you'd like, or maybe some clothes that you don't mind if they get a little dirty or stained. But just especially with what we're doing today, you just want to make sure it doesn't get your eyes because it would burn and it wouldn't taste good. So either way, I just like always saying that to parents or the kids just in case right away. So we're making our elephant toothpaste stem today. And this is so exciting because this normally, when it works out well, is not a small reaction. Now, depending on the type of hydrogen peroxide that you're using, the different percentages, you can tend to have a bigger showing of your experiment. Today, we're going to be using 3% because that is the safest percentage to use with children. But you might see in certain recipes for elephant toothpaste stem that they'll use as much as 6 or 8%. That'll definitely give you an even bigger reaction. I will say the last time that we did this, the reaction was big enough for me and I was fine with it. And it was enough that it was contained within this container here. So that was pretty good for me. But if you ever want to replicate this at home with your parents' help and you wanted a bigger reaction, you could always use 6 or 8% of hydrogen peroxide. But we're going to use 3 today. So let's kind of go over what we have provided in our kit first and other things that I think you should use from home that weren't provided in our kit, okay? So let's start out with the things that weren't provided in our kit. And then maybe we can give you like a minute or two to go grab those things. Firstly, you're going to want some kind of plastic container or tin or something that will go ahead and contain our experiment, what's going to happen, so that it doesn't get all over your table. Now, we know that it's probably really easy to clean up, but we are going to be using food coloring today if you have it. If you don't have it, the experiment works just fine without it. It's just a little less colorful, but you're going to want a container that's just going to be able to hold everything, okay? Next, something that wasn't provided would be dish soap. So I have Dawn dish soap here, but it could really be any type. But you want to make sure that you've got some dish soap just so we can get a squirt of it or two into our experiment. Next, you should have some kind of smaller cup or bowl to do some mixing of 2 of our ingredients. So you're going to want a smaller container. Next, you're going to want a tablespoon just to do some measuring. So mine is an adjustable one, which is pretty cool. It shows all the different increments or measurements that you can use. But we just need a tablespoon specifically. So we're just going to be using this one. So if you have a tablespoon measuring spoon, make sure you get one of those. Also, I'm going to use a 1 cup measuring cup. Something that we're going to be measuring out, we asked for half a cup of it. So I'm going to use just a full measuring cup because that's what I had on hand. Let's see. Finally, for the things that we did not have, 2 last things. It may just be one thing at home for you. I had a funnel at the library and it grew legs and must have walked away. I'm not sure where it went, but if you have a funnel at home, that's going to make your job in this experiment a little easier. If you don't have one, I'm actually not sure how well this is going to work out, but we're going to try it because science is fun, right? And we always experiment with things. So we're going to try it, but I wanted to show you guys, and we'll get to that then, but I'll show you how to make your own funnel out of paper and out of tape if you don't have one at home. I thought that that was just a last minute thing that would make it a little easier for us to do. You should have 1 plastic water bottle. Okay, this is where a lot of our experiment is going to take place other than our plastic container. Next in our kit here, you are going to have some hydrogen peroxide in a container. So as you can see, this container has a lid on it so it doesn't spill in your bag. Like I said, This is not water, so you do not want to drink this. You do not want to get this in your eyes, anything like that, in your mouth, nothing like that. But you have a whole container of hydrogen peroxide here. And then finally, other than that, our bag will be open and have nothing in it. Ooh. We're going to have some yeast here. And it's, honestly, this yeast, if you look at it in your baggie, kind of reminds me of like sand at the beach. You can kind of pinch it with your finger, and it's actually kind of a cool feeling. If you notice, they're kind of like in little granules, like in little small pebbly pieces. So that's the last thing that you should have. But before we utilize it, it's kind of fun to look at what it looks like first before it turns into something else. So just in case anyone did need to make their own funnel and already has the paper there, I just wanted to show you, this is another scrap paper that we have at the library. If you take it from the corner and you roll it, so you would roll in with the corner like this, and just keep rolling the shape so that the paper kind of makes the point at the bottom and it starts to make like a cone. You can make your own funnel, just keep rolling it to make more kind of like this flower shape. And then you can get a piece of tape and tape it like that. See, so then it holds it together. And then finally, this hole would be too small for any of our ingredients to go through. So you can take your scissors and just cut the tip off. So then, oh, you might want to cut it a little bigger than that. But you get the idea. So then it makes a bigger hole. And if you wanted to pour your things through, you could. Now, this is going to be a little bit of a thicker mixture that we make. So it might not flow the best through it, but we'll see. Otherwise, you could use a spoon or try to pour it in that way. But I figured I would just help out with that. So, all right, we're going to actually start with getting our stuff together now, which is going to be awesome. So thank you for bearing with me for all the intro stuff. So the first thing that you're going to want to do is take your water bottle like this and really dramatically put it in the middle of your container. So we have our bottle in the middle of our pan here. Like I said, when we start our reaction, hopefully it's going to capture everything in here. If it doesn't, we'll just clean it up, right? So we have this set up, which was super difficult, right? For now, we're just going to push it to the side so that we have room. The next thing that we're going to want to do is you're going to get your separate container, which for me is this cup. I'm going to want to take my yeast, okay? And I'm going to want to measure that out to be 1 teaspoon. So we're going to take 1 teaspoon of our yeast. So I'm going to open up my baggie, pour it to the end here so I can get the most into the spoon. And then over my container, just in case it spills, I'm going to go ahead and put the spoon in, maybe shake off the excess. And just so I don't spill it, I'll show it to you guys. Hopefully you can see it from there. That is my 1 teaspoon of yeast, okay? And I am going to go ahead and pour it into my cup. Make sure that you tap out all the excess. So next thing that we're going to do is we are going to go and I'm going to change my measuring spoon to the tablespoon side, okay? Or you could just grab your tablespoon measuring spoon. We are going to go get 2 tablespoons of warm water. So we're going to go get the water, but what it's actually going to do, we're going to mix them up after we have them in the cup. We're going to mix them for about a minute. Okay, so not too long, 60 seconds. What's going to happen is the yeast that was in this bag, okay, this yeast is not activated yet. Once we put the warm water in it, it'll actually catalyze the yeast, which means it's going to speed up the process of being able to use it.
Hey kids, fun science fact. When Miss Tara is away, yeast is actually a living organism. Each of those little sandy grains that you see is a clump of organisms that are one single cell small. They're very tiny. Technically, they're a type of fungus, like a mushroom. Weird, right? Science sure is wacky.
Alrighty, everybody. So I guess you couldn't hear me, but as I was going past Mr. Tim, I went zoom, 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 like I was running really fast. I wish you guys could have heard that, but you heard it now, right? So I got a paper towel and I made sure to just wipe off my tablespoon measuring spoon, just so that it doesn't get on the table here. That's a smart thing to do at home too. And I didn't have a spoon, so I'm going to use a pencil right now, but I have added the water to the yeast. And so I'm going to mix this up for about a minute. What you're trying to do with all the cool facts that Mr. Tim gave actually is that you're breaking down the yeast into this water mixture. So the more that you mix it around, the more that you'll see it'll start to dissolve. What we really want is not to be able to see the yeast at all anymore, okay? Now, I'm just going to forewarn you, like I always do. Science is its own beast, right? It's so much fun. But science is science because it doesn't always work out like you think it will. So I always just like to warn families that when we're doing experiments like this, they're very temperamental, which means that sometimes, depending on different variables that go on while you're doing the experiment, it may or may not be even better than the first time you did it or worse, right? So my suggestion to you is if your science experiment at home, because we're not all together, if we were all together, it probably would work out more similarly because I could go out to each and every one of you in person to help. But let's say if you pour a little bit too much water in or not enough of the hydrogen peroxide later, that might change how your experiment turns out. And I just want you guys to know that scientists all the time mess up all the time. They purposely redo and redo and redo science experiments to test what happens. So if this happens wonderfully, then perfect. But know that if something goes wrong with it, or if it doesn't completely work, that it's not a failure. It just means that we need to run another test. And I always say that during our science experiments because I think that's important for you guys to know that it's okay for things to succeed, but it's also okay for things to fail. All right, so now that I talked for more than 60 seconds, which we needed to mix our yeast and water together, that should be pretty good. So like I said, I didn't have my spoon on me, so I apologize. I'm just going to wipe off my pencil so I can use it another time. But now you should see your mixture look more like this. So it looks more like a weird colored chocolate milk, but it wouldn't taste like that, I promise you. Okay. All right. So we went ahead and we mixed our yeast and our water together. The next thing that we're going to want to do is we're going to drag our bin back over with our dramatic water ball smash right there. Okay. We're going to make sure that our yeast and water combination is off to the side at this point. We are not going to be mixing the hydrogen peroxide and the yeast mixture together yet. We're not going to mix that at all until we're absolutely ready to see what happens. Okay. So we are going to be next putting a half cup of the 3% hydrogen peroxide into our water bottle. Okay, so completely separate from our cup that has the mixture of the yeast and water. This is where your funnel comes into play. And like I said, we'll have to see how well this works out for me here because paper, once it gets touched by water, kind of tends to fall apart. So we'll see. But what I'd like to do first is if you have a funnel at home or if you made one, we're going to use it. And we are going to measure out a half cup of our hydrogen peroxide from our container. I suggest that you do this over top of your bin as well, because, you know, I mean, it's not that bad if it would spill, but it's better to have it in the container. So you're going to take your cup. I'm going to measure half of this for it to be a half cup of the hydrogen peroxide. So let's go ahead and do that now. After you measure your half cup of hydrogen peroxide, please go ahead and pour it into your water bottle. We'll see how this works out here. All right, so we poured that in. The next thing that we're going to put in our bottle is not our yeast concoction here yet with the water. We're not going to pour that in yet. We want to take, if you have food coloring, only if. If you don't, you can skip this step. We're going to put 3 to 4 drops of the food coloring inside our water bottle. Like I said, I'm using liquid food coloring, and I'm actually going to take my funnel out for this part because I don't need it. So we're going to do 1, 2, 3. Come on. And let's see, 4 for good luck if I can get a last one in. Ah, there we go. That's another good reason to use the bin. because liquid food coloring tends to go everywhere. And this, my friends, does stain clothes. So if you get some on your hands, just make sure that you don't touch your shirt or your pants or anything until you've had a chance to wash your hands after. But now you can see that my hydrogen peroxide doesn't look like water anymore. It looks like some really kind of cool ocean water or something. Next thing that we're going to do is use our dish soap. Okay, so we're still not going to put our mixture of yeast or our water in yet, but that's going to come really, really soon. Now we're going to go ahead and we're going to put, I'd say, about 2 good squirts of dish soap into our bottle with our hydrogen peroxide and our food coloring. And when I say good squirts, I mean real quick ones. You're making sure it gets in there, but you don't want to flood the hydrogen peroxide with it, okay? So let's see. 1 and 2. That's enough. But I am going to make sure I put my lid back on here. And I am going to swirl this around a little bit to make sure that the soap that's on the inside of my water bottle here is getting off the inside and into the mixture with the hydrogen peroxide. You could even, if you wanted to, put your cap back on your bottle. Make sure it's on there really good. And over top of your bin, you could even swirl the mixture around in here to make sure that you really got all the soap off the sides. You can even see there's some bubbles that are forming in here now because of the soap, which is kind of cool. Then go ahead and take your lid back off. Okay. So I think the last thing that we have to do now is actually see if our experiment works. Now, like I said, one more time, science is not about it being a success every single time. And it probably will be great, but I just want you guys to learn together with me that when things go wrong, it's actually a learning experience versus it being like, oh, something happened that shouldn't have happened. So let's go ahead and see what happens here. I'm going to stick my funnel back into my bottle, okay? Now, we're going to do a countdown before we ever pour it in. But I want you guys to make sure that you have your dramatic water bottle in the middle of your tin, just in case it goes pretty wild. You never know how crazy it'll be. You're going to hold up your funnel here, and you're going to take your cup or whatever you mixed your yeast with, okay? And let's count down from 5, and we'll pour it into the bottle. We'll see what happens. As soon as the reaction starts to happen, make sure you pour your funnel out, okay? Hopefully it works, right? Ready? 5, 4, 3, 2, 1, and pour. Let's see. Wait, does everyone see? Is there a reaction happening? Now I'll tell you, it starts slow, but it keeps going. Now look at that. This is like a mint explosion. Look how cool that is. And it's still going too. Is everyone else is doing that? I hope so. Maybe yours is a different color than mine. And it's hard to tell, but it's still coming out of the top. Let's see, the reaction's kind of getting even bigger now too. Look how much is in the bottom of my tin. Oh my gosh. And I know I have my mask on, but you can smell the soap so well. It smells so clean.
I won't lie, Miss Tara. I know I'm not supposed to encourage this, but that looks delicious.
I know, right? And that's why I said don't put it in your mouth. But it kind of does, right? Now look how much is in there now. Hopefully you guys can see that. Now, the cool thing here that's actually happening, and I guess it could remove this part now. The cool thing that's happening is, so remember, we catalyzed the yeast or made it speed up its reaction by putting it in the warm water. The warmth of the water activated what was in the yeast. Once it touches the hydrogen peroxide, it goes ahead and it makes this reaction by coming out of the bottle here. But the soap is what's really making it fizzy and fun. But it's really cool because it smells really good. And I would never expect that that would happen with yeast. Yeast and water and hydrogen peroxide. It's a chemical reaction that's taking place, making it look like this. Okay, friends. Well, I super appreciate you coming to the program today, and I'm glad that you had a lot of fun with it. I know that I did. It's just so much fun to see a different reaction. And like I said, in any experiment that you ever do as a scientist or in school or just anything in life, just remember when things go well, that's amazing. But when they don't, that's okay too. And we can always learn from our mistakes, right? And that's why science is so much fun. Like, there's lots of experiments that we've done here at the library that definitely are not perfect. They're so much fun anyway, though. So, if you take away anything from this program, that's just one thing I want you to remember, that the joy of trying something new and learning something is way more important than it being perfect or right.